my name is Ilya. Today I'm going to talk about React Native performance in React Native. And I don't want to start with a song, unfortunately, but I want to start with a story. I wrote a story about experienced JavaScript developer who worked with JavaScript, and he embraced this language, and he felt a lot of success with this language. Let's call him Bob. And he found one particular interesting framework. This framework was quite hot at the moment, and he felt like he is very powerful, he is very productive and very successful as a developer. So he felt, as a result, a huge power when he worked with this magnificent tool. And for him, for this Bob, this was very cool combination. He felt like there is no limit, there is no unsolvable problems to him. And he was very pleased with his skills, but he worked on the web, and he used this framework, this library, to be honest, like the owners of this thing called it a library, and he used the skills on the web. He used all this potential within the browser, and someone told him that he might reuse his skills. He might take his skills and move it into the native realm, like a completely different domain of expertise. And this actually was a huge promise. It doesn't seem so significant, but like this promise that you can learn once, not write once, but learn once and write anywhere. So you're not, the main idea was that you're not reusing your code. You're reusing your ideas, your knowledge, your expertise. So it's not a single code that runs on multiple platforms, but you're using the same ideas to build different stuff, different items. So time passed, he deployed this magnificent application to production. And again, with this naive power, which left still from the web, this naive feeling of power, he got first reviews, first feedback from actual users. And this was quite a significant strike for him, because remember that he was quite powerful. He felt very powerful, but these first reviews, they were very heartbreaking for him. And they were very different, different in motion, different. It's sometimes just only stars without any words that I can say it for you. But the main idea was very simple. Application is not responsive. It's slow. It doesn't feel right. So it's not like native. It seems to be that it should be like native, because again, this big company promised that it won't be indistinguishable from native applications. But users somehow distinguish. They saw that it behaves very different. And when this developer, Bob, when he tried to research, tried to fix this issue, he felt in this story called fear and loathing in React Native. For some of you who haven't heard about this fear and loathing in Las Vegas, it's a cinema about heroes under the influence of drugs, and they fear everything, they blame everything. And the main idea right now is that in terms of performance, particularly performance, in React Native, a lot of authors of blogs, they blame React Native. They say that React Native it's not immature, it's not sufficient. You can't write full-fledged applications with React Native. And so, when struggling with the influence and the blog reviews, Bob felt like there should be some positive side. There should be some morale. And there is morale to the story that you need to rethink React Native. Yes, you can reuse concepts from the web. Yes, it's true that you're using the same React. It's basically the same React as you have in the web. But the area is very different. The mobile platform expectations, basically the expectations of users are very different. In mobile world, you're competing with native applications. And it's really hard to compete when you have when you're writing applications on two platforms. But your users, for instance, Android users, they don't know that you are also available on iOS. They compare you only to Android applications, and most of Android applications are native. So in a sense, you need to take special care about performance, because you are competing on different platforms where expectations of users are very high, very demanding. And second idea is that when you don't think about performance, and again, Bob used not to think about performance, because in the web, machines are very powerful. This device is very powerful, and JavaScript on the browser is much more powerful, and as to be compared to JavaScript on the tiny small device, like my Android device, for instance. So you need to take special care about performance when working with React Native. Yes, as I mentioned, users really rarely write about, like, directly about performance. They just say that your application is crap. But there is a positive side that, yes, you can solve lots of those problems on the JavaScript level. There is no need for native skills. Obviously, there are some cases where you need to have native skills, but overall, I truly believe that not most, but many problems, significant problems, can be solved on the JavaScript level, on the React Native level. Couple of words about myself. I'm Ilya, not quite Bob, but I share a very similar story. The story is almost about myself. I've been working with React Native for 3 years now. Overall, I've worked with React for 5 years, and this includes React Native. Because when I work in the web, I'm working with React. When I work with React Native, I'm also working with React. So I'm just counting this as a total experience, just for you to know my background. Because React Native is quite interesting technology, where like lots of people are coming to React Native from different realms. One of the realms are web development, another realm is native development, particularly like iOS and Android, which are also very separate by themselves. So I came from the web. I'm talking about JavaScript. Why this talk? Why I want to share my ideas? First of all, obviously I want to talk about performance, duh. But not only about performance. I want to show you some ideas that performance actually is connected. It's connected to different aspects of your application. First of all is developer experience. It's also called maintainability or velocity, is how easy and how quick I can iterate over my application. And also about correctness. And when you change your performance, you might break something. This also relates to maintainability. When you fix your performance, you might decrease your quality of your application. Developers might feel like crap again when they work on your optimized version. So the application runs very fast, but it's really trouble to work with that application. Yeah, and I'll try to cover everything as interrelated aspects. I'm a little bit nervous because this is basically the hard part of this talk. This talk for me is very hard because it's really tricky to talk about performance in isolation. If I talk about performance, you will get lots of reviews that, yes, premature optimization is the root of all evil. Performance doesn't matter. You need to have some different parts of your application. So I just try to talk about performance in relation to other parts of your application. I will show you more examples of what I mean. Basically, this talk contains of 3 parts. First is rendering, how we can reduce the number of rendering in our applications, how we can reduce the amount of redundant renders in our applications. We'll talk about different ways we can deal with raw code. And in the last, very few words about animations. Unfortunately, I can't dive into animations, so just a couple of minutes about animations. So first of all, about rendering. For this talk, I've created a very simple application. It's media application in the media domain. In Wix, I work with media. We are working with music, videos, live stream. And this application shows you top artists for your country. And you can see statistics, like what you select, the overall statistics, how many artists have you selected, and how many total listeners those artists have. One of the key features here is that you can see that I can load many artists. Maybe it's hard to see, but at the top you can see how many artists I have right now. It's 50, then it goes to 100. That's basically the idea that you can have, this list is lazy loaded, you can have a potentially infinite amount of artists. So in terms of rendering, I want to focus on 3 parts. First is why should we care about rendering? Why I'm talking about rendering in terms of my performance talk. So second is I want to focus on where should you focus when you understand the why part, is where should you place your focus? Where should you focus when you optimize your mobile applications? And the last, the most technical part on how actually to optimize your mobile application. So first is let's talk about why. Like why should you care? When I worked on this mobile application, I first created a very simple, naive implementation, just to get the business logic right, and I paid 0 attention to performance. That's what I've got. I've got this, I will decompose it deeper, but the main idea is that I am selecting System of a Down artists while having 100 artists. Let's dive deeper. Let's analyze this frame by frame. I want to get some metrics. I want to get some data. Here I'm using QuickTime. So you can see it's a little bit small font, sorry about that, but basically this is a time frame from QuickTime, and what I'm looking here is when I start interaction and when I get my feedback. So I'm looking for two metrics here. First, when I press on the button, press on the artist, and second is when I get this border, when this border in this case disappears. So as a result, I will get that response time is equal to 500 milliseconds. For 100 artists, when I press on an artist, 500 milliseconds passes, and I see some feedback. I see that UI has changed. I'm trying to ignore this opacity, this touchable opacity. I'm trying to ignore it. I'm trying to get the feedback of my actual action, my actual action. Yeah, no, let's leave it as it, actual action. Yeah. So second case, I want to show you what does it look like to have 300 artists. Same behavior, same action. And let's do the same stuff. Let's also analyze timeline. And for Deftones, while having 300 artists, I get these metrics. I have press and reaction. And time is much longer. I have almost 2 seconds. Again, this is like just objective data, just measurement. And if you compare, we see that it's not only that 500 milliseconds is quite slow, but it also decreases. In my naive implementations, the more artists I get, the slower my application. Yeah, almost linear. Yeah. And there is a golden rule in psychology that it's just a heuristic, just a convention to that humans start to notice after 200 milliseconds. Your users will start to notice that your application halts. It thinks something. It's not written in stone. It's just a psychological metric. And here it's not the case. It's not only that it's at 500 milliseconds is bigger than 200, but it also grows. That's the tricky stuff, that it grows linearly. In other stuff, Edvidas talked about bridge. Remember, he showed you the bridge, JavaScript, native part, and JavaScript is single-threaded. And this is actually a fundamental feature of JavaScript. This has nothing to do with React Native. But the idea here is that here I'm actually showing you the case when I'm quickly trying to select 4 artists sequentially. Unfortunately, you cannot see my fingers. This is recording from the real device. But the idea here is that I'm quickly trying to select 4 artists. And the idea here is that if your application is slow, its slowness would stack. Here, when I select one item, and while I'm selecting another item, JavaScript puts my interaction in the queue. So while it's still processing my first interaction, I'm inputting its third interaction. So it puts its third interaction into the queue. And this accumulates slowness. So if your application is slow and you have fast users, they will see much more regression. They will see much more slowness of your application because slowness would accumulate over time. And yes, so it stacks. Here's, I will show you the quick version without any metrics, just to give you the feel. This is the slow version. This is a quick version. This is more optimized version. And you might guess how users might be frustrated when you don't pay attention to performance of your application. So yeah, yes.
I have a question. Have you tried to press, let's say, 10 artists very quickly, and what will happen?
You mean I haven't tried 10 artists? You mean what is the limit size of the queue?
No, not like the limit size of the queue, but I imagine we know that state is asynchronous in React, right? It's not synchronously.
But changes to the state. State itself is an object. It's changes. Yeah.
I mean, when you said set state, I'm sorry.
Yeah.
Set state. Yeah. So, I just wonder, when you have multiple set states basically happen, what I would experience as a user, just this. So I would press, and then after some time I would see the same exactly.
It's tricky to answer because even if you have a desired state, if you know advanced topics of React, you need to have reconciliation to take place. So even if my state has have some number as 2. I might still see on the UI 1. In this case, if you have multiple changes to the state, the problem might be accumulated. But your events, your interactions, callbacks to be more precise, would be stored in the queue. And if you click 10 times, you would see the very similar effect. You would also see that when you click 10 times, you would see very small, tiny steps of animations.
So basically, that's what happened to you. So you pressed that.
Yes.
I'm trying to clarify, I didn't quite yet. So you pressed it, and
yes.
it was just slowly
reflecting
your touch.
Yeah. Right. And these reflections would all be internally within the set state. Yeah. Cool. So just again to summarize that it's not bad to have slow application. It's bad, but it's even worse when your application performance degrades over time or degrades over some data when you accumulate more data. Because in case of React Native, because of its single-threadedness, your performance degradation might stack because you have multiple interactions and JavaScript couldn't handle them like in parallel. It's single-threaded. But the good news is that we can handle this. We can solve this issue of JavaScript within the JavaScript. Like we are fighting JavaScript with the JavaScript, so it's fine, it's cool. There is a solution for this. Like second point, I want to focus on where should we place our efforts when we try to optimize, because obviously you can't optimize everything. It's useless to optimize everything. And from my experience, I saw that the biggest places in terms of optimization is to focus on the areas when your one component outputs multiple components. That's why the simple pattern. Just you don't need to take all of your applications, but focus just heuristically or empirically. Focus on the areas when you have flat lists or maps, just sequential data when your one component outputs many components. In my case, it's artists, or actually to be more precise, page outputs multiple artists. The big issue is the second point, that I, as a developer, have no control over how many artists would be on the page. It might be 100, it might be 1,000. So if I want to optimize, and I have a very tiny relationship between the number of artists and performance, then my performance might be very, very slow. Again, because I don't have any control on how many artists user would see. Just again, oops, sorry. Yes, just again to reflection of what I meant is if we have a page full of artists, structurally it's shown as tree of elements, tree of hierarchy. It's not necessarily React components, but like semantically, it's just a page full of artists. Each artist has a status bar. Just to remind you, status bar is to the right. Is this green stuff shows the relative popularity of the item. So what happens when I press on the artist 2? If my poor implementation, by the way, who knows about big O notation? Anyone heard about it? Okay, so not all of you. Big O notation is used to show the complexity of your algorithms. How long it takes, for instance, to find the biggest element in a sequence, or how long it takes for you to sort an array. In this respect, I'm showing you how long it takes for you to update one item. In poorest case, you need to to take all the artists, execute render on each artist, and then take a status bar which contains of boxes, and for each artist update the status bar. So lots of redundant renders. Our goal is to have that to have the case when you update the artist, you need to update only one artist. Not to update status bar because no changes have been made to status bar, and definitely not to update other artists. So it's to have constant of one, regardless of how many artists you have on your page. Just again, to summarize, is just this is very simple, non-technical suggestion to focus on the ideas when you have lists, flat lists or maps, iterations over items, and ignore other stuff, because usually developers try to enforce some rules within the whole application, but they lose some focus. They try to optimize everything while achieving almost nothing. So this is just wanted to share where to focus your efforts. So now we are going to React. We just ask you a question about React Native, but I want to ask you about React. How many of you are comfortable with React itself, regardless on the web, in the React Native, like the React itself? Yeah. Okay, so I might try to make it simple, but this is very simple. This is very simple concepts because they are very simple optimization points. But I will go through them. I will try to make it simple and easy because we have lots of materials. We might get it a little bit longer than I expected. But my main idea of should component update. This is optimization point. Each component for each component you can say should you re-render yourself if the state or props have been changed. This is a very simple idea, but lots of developers lose context. Like if you are familiar with React, React has this notion of context when you can pass properties indirectly into the child components. So basically, should component is the optimization point, purely optimization point, which asks one question: should we re-render itself? It's having state or props or context changed. And this is very simple, very naive example, just to remind you that what should component is. It takes lots of stuff, and here we're just subscribing. If the ID of the component has been changed, only then we will render itself. If anything else has been changed, like rockets flying, we still won't call renders. That's the basic idea. Pure components and React Memo are like implementation classes which override should component update, and they define their own custom behavior. They go through each property on state props and context and use shallow compare to see if they changed. And this is very crucial. You need to understand that shallow compare doesn't go deeply. They don't iterate deeply into the structure of your props, state, and context. Yeah. So having said all of that, like the naive version is to take pure component and apply it everywhere. Like replace your components with pure components, and if you do this, nothing would happen. Like your performance probably in most cases will still be the same. What you need to do in order to optimize your performance is to look how you are using your components. Not only how your components are written, but also how you are using your components. So here is an example of how I wrote on my first iteration, my artist.info. Again, to the right is what it looks like on the UI, just for you to recall. And to the left, these are versions of your properties, versions of how I'm using those properties. Yeah, for those of you who know React, regardless, yeah, I wanted to ask, how do you think how many mistakes I have here? I have 4 properties, and some of them are wrong, obviously wrong. Some of them are like maybe, might be wrong. So I have from 1 to 4 mistakes here. And I want to ask you, from 1 to 4, how do you think it's only 1 mistake here in terms of performance? Right now we are looking for mistakes which will break pure component. Some usages of my artist.info which would obviously break performance optimizations of pure components. Okay, how many think there are 2 mistakes? Go. And 3 mistakes? Go. Yeah. And 4 mistakes? Yeah, good. So yeah, there is no obvious answer, but my approach here is that here are 3 hard mistakes and 1 soft mistake. So overall 3.5. Yeah, but yeah, to be honest, there are three obvious mistakes. Like the answer 3 is correct, but I will.
Sorry to interrupt, but could you turn off Flux?
Yeah. Sorry, guys. Yes. Just a second. Yep. Yes, it should be disabled for full screen. Yes, disable.
Thank you.
You're welcome. Martinez, where have you been earlier? but yeah, sorry about that, and we will dive right now into the code. Yeah. So let me first explain what does it mean, like overall. What does it mean overall to break pure component? What does it mean to apply pure components but still get no benefits? So suppose we have a couple of components to the right, and these are 2 pure components. The implementation includes either React Memo or the implementation of pure components, and I'm using it like this. I have my parameter, and I'm passing in JSX, I'm creating an object and passing a property within this. What does this code means is that this would completely ignore pure components. In JavaScript, as I've mentioned, pure components are using like strict equals, triple equals. And triple equals behaves for instances differently than it behaves for values. And instances in JavaScript are objects, arrays, and lambdas, and all that kind of, yes, I think, yes, even, yeah. And on the other side, you have values, which are numbers, strings, undefined, null, dates. So this logic behaves very different for those 2 sets of values. Let me show you one set of values. This is a set of instances. Like empty object doesn't equal to empty object. Like JavaScript would return false. In this case, pure component would see that you have, notice my parameter, and here I'm always creating a new object with a defined property. And this, to be honest, this is very simple. I mean, this is. Let me share one story of experience. Like I've been interviewing lots of candidates, and guys and girls usually understand this concept. They say that yes, in this case we are always creating a new object. So your component won't understand that for my property you're passing every time a new object, and you'll always get this second case. You'll always get false, even though they are structurally equal. They are identically different. And strict compares it uses identical comparison, not structural equality comparison. Understanding this concept, they are still, when working on the projects or writing test tasks, they will still like fail to see these patterns when implementing lists. They still write lists with lots of items within them, but every time you change one item in a list, they will still get updates within the whole list. And this is the most significant performance implications, performance degradation. So here I'm talking about, it seems like simple stuff, but from my personal experience, like knowing and doing are sometimes different. So yeah, that's my disclaimer, why I'm telling you like what meant to be obvious stuff. But sometimes it's very tricky, even understanding this stuff. Sometimes it's very tricky to implement this. So yeah. Coming back to the slides, here is the stuff which is for strict equals returns true. It's strings, numbers, and all the like other primitives like null and defined even dates. So we need to understand that when we create new instances within the render, pure component won't pick them up. So let's try to fix artisan form. This is like very straightforward approach, actually. When you understand why this happens, knowing the how is quite straightforward. That in order to fix on press, we just don't need to create our lambda, at least on this level. What we can do, and also, yes, and this is how I'm using this definition of artisan for this like internally, and notice pure components. Yeah. So what I can do is I can create additional parameter ID and always pass on press here. And we only create lambda behind pure component. This is what pattern I call it to hide a creation of lambdas under the pure component. In this case, the instance of onPress would always be the same. I'm always passing the same instance, and thus pure component would always like return true because the instance is the same. But this would fail actually. To be honest, this won't work. Like set state is not defined. This won't launch. Does anyone know why? Like why this happens? Just a raise of hands, no spoilers. Cool, yeah, good. What is the fix though? Like, what is, how can I fix this?
Move it into in your return. Move it into the second function.
Like here?
Yeah.
But you would still create an instance of this function.
You asked for a fix, you didn't ask for...
Okay, yeah. But in that case, you will need to remove this pure and just scratch it out and not to bother yourself, yeah. But like the most common solution is to use arrow functions. I'm making the bold my changes, and this idea that arrow functions use lexical this. In this case, this would point to a correct instance of your component. So this is a performance fix. You won't get any errors. Everything works fine. But this breaks hard reloading. Like Edvida showed you like the real benefits of hard reloading. When you change something in your code, you immediately see this feedback. You immediately see the changes, and no need to like reload your page. Like imagine if you have 20 screens, or you have some error screen that your network out of reach, and you want to change title, and you are on that screen. You are changing title, and now what? I need to reload my application, go through again this cycle. So it's like hot reloading is a huge performance benefit. And for me, like originally when I thought arrow functions, it was like cool. Finally, I can solve this problem. Because this problem in JavaScript is canonical. It's like lots of religious wars would be fight against these problems. But the idea that even though this arrow function solves this problem, but it like injects lots of maintainability issues because you're losing hard reloading feature. And Facebook originally was advertising React Native with this hard reloading feature, like very hard reloading feature being very hard. Like lots of bummers there, yeah. But again, I'm highlighting that when you fix performance, you should also take into account other areas of your application. It's not only about performance; it's also about like maintainability or your correctness. So yes, there is a link on GitHub. You can see the thread that yes, arrow functions, they not the way to go. What are the solutions? Like, how can we achieve like correctness of our application, performance, and maintainability? So we get this hard reloading. One of the solutions is to bind each method in a constructor. This like, so you can kill yourself already, because like, every time you add a method to your component, you will need to update your constructor. So this also like, it fixes one area of maintainability, but introduce another issues. Better way is to use external libraries like autobind. This is much better because you've just wrote it once, and you just forget about this in the constructor. So it's more maintainable in a sense that you have only need to write it once. There are also Babel plugins. I'm not quite a fan of like changing the way React Native works with JavaScript, because it might it loses a little bit of code reuse. Like, you wrote your component, and it works fine on your project, and you take this component, place it on a different project, and it fails. Why it fails? I'm not using this Babel right. So every time you change your Babel transformation, you need to be very careful. It works fine, but it has some other drawbacks. Like, personally, I see the most balanced way is to use something like autobind. For me, and you can write your own. The implementation is very simple. So just again, to be clear, that arrow functions are great, performance is great, but maintainability is also quite important. Let's come back to the other properties. Styles. Here, I'm using styles, obviously improperly. For font styles, it's quite kind of simple. Like, you just take the style because it doesn't depend on any state. It's just constant object. So you can place it under style sheet and reference that style sheet via the variable. Very simple. But with artist style, it's a little bit trickier, because it's not tricky because it's array, but it's tricky because it's a little bit dynamic. It depends upon like some criteria. You don't know what the style would be. I would share one approach is to cache. Again, I've bolded my changes. Is to cache the whole array. So you cache styles for selected artists, and here in the render you decide if the artist is selected, use that cache value. Otherwise, use the styles directly. Why I'm using this approach is not to have duplication in styles. Here I can define some border size, border radius for the artists, and then just to adjust specific types or for specific styles in selected artists. I can duplicate. I can create two different properties, and just if artist is selected, use one property. If artist is unselected, use another one. But again, I want to have maintainability. I don't want to duplicate my styles because it's very, very error prone. So this again shows you the tiredness of your performance of caching styles and not copy pasting them, but to cache them smartly, so that you can adjust your styles quite easily. Yeah, to summarize, these are the common troublemakers. Try to avoid creating instances of objects, arrays, and callbacks in your render functions. This is a very simple rule of thumb. But when you approach this with the criteria I've showed you, that in each flat list you would adhere to this criteria, you would get much more faster application. How fast? Let's see. So I've made these changes. I've implemented my pure components properly, and now I'm searching for the same timeline, but for the optimized version. Again, I'm checking deftones. And I'm working through the timeline to pick up like what is the correct time frame. Don't bother to see the exact numbers. Just showing the process. That it's so much easier actually to do this. And I've got these results. That for 300 artists, I got 150 milliseconds. Just following very simple rules. The rules are simple. You saw them. They're very tricky. Like if you ask those questions on the React interview, like the candidate would laugh. Why do you ask so simple questions? I thought we'll discuss more trickier areas. So following this results, you would see that we've first of all got rid of this like 500 milliseconds, but now also we have like almost constant complexity of updating your item. It's not constant, obviously, because of the flat list implementation details. I'm still firing render items. I have still lots of items, lots of JavaScript is involved, but it's not linear. It's like at least the coefficient of the linear function is much flatter. So this is basically the influence that you can do just purely on the JavaScript level, not taking any parts for the native. Now, for some of you about this fourth argument, this is like double. I thought about this quite for a few hours. I thought about should I add this to this presentation about this parameter, and I figured out to add this. Like technically, let's figure out what does it mean. Each artist has a popularity from 0 to 1, so it's floating point number, and we pass it as parameter, and this basically signifies how many boxes you have filled at the top. That's semantics of it. How I'm calculating it right now. For each artist, I'm currently taking current listeners and divide it by the maximum listeners within the given set. So if I have 100 artists, for each artist, I'm taking this popularity and divide for the artist with the maximum number of listeners. So this means that my popularity is based on the biggest artist within my given set. Makes sense. So if we take an example, we have 3 artists. One has 3 million listeners, one has 20,000 listeners, and last one has around 1 million listeners. So we get this artist, just a sample set. When I load more artists, and it happens to be that one artist there has has one more listener. If I add artist D, just load data from the network, and this artist has one more listener, you won't see the changes on the UI, but every component needs to be updated because the value has been changed. You can see that values to the right are different from the values to the left. They are different by value, but you won't see this on the UI. In this respect, when I worked with performance in my applications, when I loaded more artists, I saw that for some reason, for some interesting reason, I will see lots of redundant renders, but I don't see why. Like the UI is still exactly the same, pixel to pixel, but for some strange reason, not for your country, but for different countries, there was an artist which later was much more popular than first artist, and this leads to the idea that you don't need so much fractions. You don't need so much precision. What you can come up with is to count popularity as this one, as integer numbers from 0 to 100, and just to round it. Take the same fraction, but to round it. In this respect, let's go with the same scenario, that you have the same set of artists, and new artists arrive, and you don't need to update anything because the values are exactly the same. And notice, this is very different from what I've told you previously. This is in addition. Like this is, I want to show you this case, advanced case, that there is much more to performance than just making sure that your objects, lambdas and arrays are right. You also need to think a little bit about your data structures. Do you need so many precision? Like every time a little bit of precision has been changed, you don't need your whole UI to be updated. You want to take more control about how many updates you have on your screen. Well, that's a very different idea, but I wanted for you to have more vision about different disoptimizations that you might have. A couple of tools. Again, you have lots of choices to focus on your renders, and these tools are great. But every time I enable those tools, I get so much information. I get so much information that I'm just overwhelmed with that information. It's too much for me. It's unbearable. So I don't want to go over these tools, but you can check them out. I will give you links to this presentation at the end, so you can check them out. It's just, for me, I use, again, in the 21st century, but I'm using console logs, actually. It's a very, very productive tool because it's deterministic. I know where I put them, and it's easy for me to write them. But the last one is a little bit new for me. I've been using this for maybe 1 year. It's this pattern. It's not a library. It's just a pattern. It's called Sandbox Pages. It's like you're using Storybook, but without actually using the Storybook library. It's using the same concepts. Like in practice, what we have, and in Wix we use it a lot. What we have is that we have only for development mode. You have a separate page when you try to create a sandbox version of your components. If I have artist info on that sandbox page, I might place 2 artists and click them and check how they behave. And in this minimized scope, I don't have this myriads of informations. I'm not this dog where I have lots of information flowing at my face. And within the sandbox page, you can use those tools. It's much easier to use profilers, for instance, because you don't get that redundant information. When you profile only 2 components, it's much easier to see what's going on there, what is wrong within those components. So that's about tools. A little bit of summary for rendering. As I've mentioned, measure on real devices. That's a quote on Premature Optimizations. That basically means that it's good to have some real numbers, like objective numbers. taken from the real device, from the production builds, from the real devices. And here, like as I mentioned, it's very nice to identify some places where it's not only slow, but it's slower over time. It becomes slower and slower, and just in terms of performance to identify those places. Good. So we've talked about rendering, and I will go through other areas very briefly. And the main part was within renders. As I've mentioned, like the biggest drawbacks are renders. Other items are quite insignificant in comparison to renders. So slow codes. There are only two types of slow code. First type is very synchronous, like sorting a huge item, a huge array of items, or just finding some item in a huge data set. And a second one, some external code, is just using some external library, like autobind, for instance. But oops, sorry. So I'll take example of slow synchronous code that you need to find some items within the huge data set. And don't bother with the details. Just mention that I have like a huge number of items, and I'm iterating over those items. So clearly, it would take quite a bit of time. And in the render, I'm seeing if the state is running, I'm showing some loading indicator. I'm showing to the user that we are fetching some data, we are processing some data. And here I've implemented different scenarios how we could perform the same operation. You can see that on the UI, I'm showing you the number of iterations. And within those iterations, I'm creating random numbers and finding the biggest and the smallest number, just to make it, I don't know, not practical, not usable, but practical. And here, when I clicking on set state, on the set state function, my second parameter is a callback. Maybe not everybody knew of you that when you set state, you might fetch second parameter to which will be executed. What state would be updated? Since state changes are synchronous, so every time you update your state, you can subscribe to those changes. In this case, and update UI. Like the biggest drawback is notice how this button behaves. It doesn't behave nicely. Like when you press on the button, you can see that it stays opaque. And it's not responsive enough. Much better approach is to use interaction manager. Like it was designed specifically to handle animations and to postpone your long-term operations. Like notice how this button behaves. This is again about animations and about nice user feedback. Just for comparison, you can compare like the old button, set state, but just aligned differently, and that button. Notice how they behave differently. And overall, with this item, you can also see loading indicator, which means that state updated, but state changes were propagated to the UI. A couple of words about set timeout. Like again, I thought about this. Should I add this into the slides? And what the hell? So you can use set state as well, but and it works fine. Like you see the behavior is quite the same. But please don't use this one. Like I've met so many times in the code bases when you have this magic number, like set timeout, and this 250. That means that you're waiting for something, but you don't know what you're waiting. You're waiting for something. And the drawbacks of this is that you might have some race conditions. You don't know like when this callback would be called. And since you are not subscribing to any events, but you are waiting for a magic number, you are waiting for some unknown period of time, you might get very tricky behavior in the future. For instance, some other developer might add some functionality which would be interweaved with your functionality. So just from my experience, I've been solving lots of problems like related to this pattern. Right now, like every time I see this, yes, and you can see that I've noted here that it really boils down to correctness. It is much better to subscribe to some events than to wait for some magic period of time. Every time I see this, I just want to change it to 666. I don't know why. Just to change it to 666 and then to watch the whole application burn. Like. And regardless, because it won't behave properly in the first place. So what the hell? So next one is about slow code, but you don't control this slow code. You want this slow code is external to your application, and there is a very simple solution. Maybe you've heard about it, but it's to inline your requires. Here you can see that I'm importing some heavy library. When you import this library might do some stuff. It might contain lots of JavaScript. So just to inline this, you use this technique. Just to inline your calls, and you won't call this library until the onPress will be called. You won't import this library. And this is very, very useful to improve your startup time. Yeah, that's it for the slow code. You see, so we are going quicker. This is good. Everything is good. So couple of words about animations within this application. And again, I will show you I will give you the links to the code and the Expo implementation in the end of my slides. But here, just to show you that I want to have this kind of fancy animation which just appears at the top. And there are multiple ways to approach this. But I will show you a little bit of code, but my main idea is to show you a bunch of code here. So this is the implementation, very naive, straightforward implementation. Again, no need to go to the details. Like, look, now it's much easier with this focus. Yeah. So what I want to focus is only 4 lines, like four lines of focus. That I'm creating animation, and I'm changing this animation here within the JavaScript. The main idea, and remember the talk by Edvidas, that we have this bridge. And this message, you've asked a question about serializing the event from each time you press the button. So here we are serializing the item each time we scroll our list. So this is, yeah, this is messy. But it doesn't have to be. There is no need for this one. Because we have a different approach. So there is an approach which avoids the serialization. Here we can create a flat list. Again, and I will give you more focus. We can pass styles to this header. And basically, here is the animation, which, sorry, my animation screwed up, yeah. But yeah, sorry about screwing animation, but the main idea here is that there is API in React Native, which is use native driver. This API tells React Native to animate purely on the native thread, without serializing and deserializing events on each scroll time. And there are advanced declarative ways to combine your logic, to combine how your scrolls are related to your styles. And this is, you don't see any like if statements. You don't see any loops. This is a declarative way to say to React Natives, hey, I want this scroll position to be dependent upon this header offset in this way. And it would take all of your definition, serialize it, and execute purely on the native thread. So no need to touch bridge on each scroll of your flat list. That's it for animations. That's it. Let's summarize our whole talk. And sorry about taking a little bit longer, but we are almost ready. First of all, my message is you don't necessarily blame React Native for its poor performance. Most of the time, it's like we are not using React Native properly. And that's also seen in the native mobile world. I've spoke a lot of the native guys. They also see that like, when you write in Java, it doesn't mean that your application will be fast. Like just the statement is like is true that when you pick up Java and running Android applications, that not necessarily means that your application will be fast. Same with React Native. If you pick React Native, it doesn't mean that your application will be slow. It might be, as I've showed you, but if you take care of performance, if you take more precision, it might be much better than we see right now in lots of the articles about cons of React Native. As I've mentioned, like, you can focus on the JavaScript and solve a huge deal of problems just purely on the JavaScript level. And when you fix optimizations, try to focus on your measurements, on the measure on real devices. As I showed you, it's quite easy. You just run it, take recording, measure in the timelines your interactions, and you would get like objective data of your interactions. Yes, and this is a guideline to focus on the parts one-to-many relationships. Yes. As I've mentioned, optimization is dependent upon correctness and maintainability. Don't forget about this. And last message is that, yes, having said about performance, it's much better from my experience to have more renders than fewer. It's best to have the exact right of renders, but I've spent so many times fixing some bugs where you didn't get enough renders. You changed some state, but the UI haven't been changed. And when you try to decode, you see that, here should component update, and it's overall, it's not defining the changes to those properties. And you've spent like a couple of hours just to find this particular bug when you don't get enough renders. So don't bother with having too much renders, and focus on correctness as well. Yeah, that's it, guys. Thank you all for your attention.